Hi guys, this is for I Want to Believe, lesson 6 in the Algebra 2 book. We are on page 93. So the learning goals today are rewrite expressions involving negative roots using I, rewriting expressions involving imaginary numbers, right? We talked about that before on the last lesson, and calculate complex roots of quadratic equations and complex zeros of quadratic functions, and interpret complex roots of quadratic equations and complex zeros of quadratic functions. That seems like a lot. Oh, we're also going to be looking a little bit about doing some operations with complex numbers, as well as some graphing as promised from before. So the warm up here today took a little bit of time, but again, if you're being asked to determine the zeros of each function, right, or of the function, I would put this in your notes somewhere that this is, and a lot of people are having questions about, like, what do I do when? Like, I don't know, right? So this is how to know what to use when. Okay, when there's only one x. So basically x is only in one place. So if you look over here, number 1, x is in 2 different places. I have an x squared and a minus 4x. So there's in 2 different places. So can't use this strategy. We can't use the just solve for x strategy, because x is in 2 different places. So here you go to the second option, which is when there's more than one x, which is like number 1. And so we could first try to factor, or we could use the quadratic formula. So if you can factor it, if it's factorable, I would go that route, just because there's less likelihood for error. Okay, so for number 1, and if you notice right here, for this class we did actually use a quadratic formula, but I'm gonna show you here that we can actually factor it. And so, because this one is factorable. So first things first, we got to set it equal to 0. So x is equal, 0 is equal to x squared minus 4x minus 4. Okay, so this is for number 1. All right, and if you don't remember how to do this, then keep on watching. If you do, try and do it by yourself, unless you already did in class, in which case you could fast forward if you want. All right, I won't know, my feelings won't be hurt. So remember, for factoring, you use a number that's the coefficient of this x squared, which is 1. Well, what times what is 1? Well, 1 times 1. And then you ask yourself, well, what 2 numbers multiply to 4 and will add up to a 4? Well, like 1 times 4 multiplies to 4, but when I add it, it'll give me 5. And if I subtract it, it'll give me a 3. So that doesn't work. So my other option is 2 and 2, right? So I'll go 2 times 2, right? And if I go, I did something wrong. Oh yeah, I was like, that doesn't make any sense. Yep, I forgot. That should be plus. Woo! Some of you guys maybe you noticed that and you're like, Miss Lee, it's wrong. Okay, phew, got that right now. So now we're going to multiply. 1 times 2 is 2. 1 times this 2 is still 2. Now, which one of these has to be negative? And you're like, well, both of them, right? That was already in my brain. That's probably why I made that mistake. And when I add these guys up, it's going to be negative 4. And again, if you notice right there, this guy right here, the same as this middle term right there. Remember when we add those 2 terms up, right? So that's where we're getting that from. And then from there, we're just going to go straight across. So it's going to be x minus, should have been minus 2, right? Because don't forget, if you did what I did not add those back in, that's me for days, right? Story of my life. Forgot to put in my negatives. All right. So then from here, remember, we're going to use the zero product property, which says that if we're multiplying 2 or more factors, that we could set each factor equal to 0. I can't talk. So x minus 2 is equal to 0. And then, well, this is the exact same thing. So why write it down again? Well, I'm just gonna, just because it's a video. All right. And then, so we're just gonna solve for x right there. So we're gonna go plus 2, and I get x equals to 2. Oh, that's not equals to 2. Same thing here, plus 2, x equals to, yep, still 2, right? So how many answers do I actually have? Just 1, right? But the reason, but notice how it came out 2 times, right? That's why we call it a double root, right? A double root. So remember, like if we're to graph this guy, it would be at, here's 2 right there. It would be like double root, boom, just like that, okay? And then if you take a look at So here, if you take a look at number 1, if you want to try the quadratic formula way, because a lot of people messed it up with the quadratic formula. Like they set it up right, like they put in the -4 plus or minus square root b squared minus 4. They did all of that right and then got the wrong answer. Like, so in your calculator, please practice this, okay? So you should end up getting this -4. Make sure you put the parentheses around that. That's super important, or else you're going to get the wrong answer. Sad days, okay? And then you should get 0. Boop, boop, boop. Calculate that in, all right? And then, and then we're going to go 4 plus or minus, well, 0, because square root of 0 is 0. And if you don't know that, you want to check, you'd be like, okay, square root 0, see? 0, right there. Right there. I don't know if you can see that. Oh, stinking. No wonder you couldn't see it. Square root of 0. Now do you see that? See? 0. Okay. It is 0. And then so remember it's 4 plus 0 and then 4 minus 0. So I wrote it out here. You don't have to write it out. Sometimes it helps to write it out just so that you can see clearly what we're doing. And again, you notice we get 2 both times. So we just say x is equal to 2. Double root. Okay, so now we're going to go on to number 2. So number 2, remember we're setting that equal to 0 because we're looking for the zeros, which is i.e. x-intercepts where y is equal to 0. And we notice here, oh, I only have one x in only one place, which means we can just solve for x, like how we've been doing since Algebra 1, right? So again, we added 25 to both sides, right? And then we're going to get rid of that square. How do we get rid of the square? Some people still don't know. Square root it. So the way we get rid of square is to square root it. Square root both sides. Do not forget to add the plus or minus. And then what is the square root of 25? If you don't know, use a calculator. But if you do know, well, think about it. What times what gives you a square root of 25? Or gives you a 25, not a square root. Is a 5, right? So that's what the square root of 25 is. And a lot of people did this, like straight up. Like they said, oh, a square root of 25 is square root of 5. Square root of 5 is not equal to the square root of 25. Like they are not equivalent. It just doesn't even make sense. So please don't do that. Once you've used up the square root, it doesn't just stay there. Okay, it is disappear. It's gone. It doesn't disappear. It gets used up. Okay. So here we go. So that's going to be just 5, and remember it's plus or minus. So we do have 2 answers here. So you can write it as plus or minus 5, or just 5, comma, -5. That's it. No parentheses, no nothing, just that's it. Okay. And then for number 3, what method are we going to use? I notice here I have only one x, which means what? Just solve for x. Okay. So for number 3, again, remember it's when we have more than one thing going on. So you always resort back to PEMDAS, right? But it's going to be reverse order of operations. When you're solving for something, we're doing opposite. So we're undoing what's been already done, right? So if we're undoing something, like when you zip up your jacket, how do you get out of your jacket? You don't zip it more up, right? Right? We go down, right? We reverse that operation, right? So in the same way, normally when we're trying to do just evaluate something, right, simplify something, we're using order of operations. But when we're solving for x, we have to undo all that thing, the thing that we did. So what do we need to undo first? The add and subtract, right? So we're like, oh, well, you may ask about, well, what about this -1? Why don't we do that first? That's a minus, right? But I was like, oh, remember, it's also inside of parentheses, and parentheses are last. That's the last thing we deal with. Okay, so we're going to deal with that very last. Okay, but this -9 is not in the parentheses, so we're going to deal with that guy. So that's why we added 9 on both sides. Okay, once we add 9 on both sides, then we have like this x minus 1 squared, and then equals to 9, right? And pretend like you don't see all that. But what do we do first, the parentheses or the exponent? You're like, oh, well, okay, multiply, divide, we didn't have any of that. Oh, the exponent, that's next. So how do we get rid of a square? The way we got rid of it before, right? You square root it, right? And then so the square root of 9 is 3, not the square root of 3, just 9, just 3. Okay, so the square root of 9 is 3. And again, don't forget your plus or minus. And then now the square and the square root, they cancel out because they're inverses of each other. They undo each other, you know what I mean. And so that's x minus 1. And now we can deal with this minus 1, plus 1 on both sides, and we get it to the other side, and we get, okay, literally I just flip-flopped this, sorry. I just don't like my x's on the right. So x is equal to 1, right? We got the 1, plus or minus 3, right? And if you leave it like this, I'm going to say equals, simplify it like it's not done yet. Keep on simplifying it until you cannot simplify anymore, all right? And then so it's going to be 1 plus 3, which is 4, and then 1 minus 3, which is negative 2, okay? If you need to write that out, write it out. All right, so there we go. And then for a last one, number 4, if you notice right here, we were going to try and factor that, because remember we have x's in 2 different places, but I don't know if you noticed right here. Okay, so let me just write it over here. So 2x squared plus 8x plus 5. So what I would try first is, okay, so my coefficient is 2. So I know it's 1 times 2, right? And this is 5. And the only thing that multiplies to 5 is 1 and 5. So I'm going to just go 1 and 5. So if I go 2 times 1, see here, this is where it really matters, is 2. 1 times 5 is 5. I can add those up to get 7, but I don't get 8. And if I subtract it, I'm not going to get any closer. So that doesn't work. So then let me try, instead of 1 and 5, let me try 5 and 1. Okay, maybe I can get it that way. I go 1 times 1 is 1. 2 times 5 is 10, right? And 10 minus 1 will be 9, but it doesn't give me 8. So that's how I know this is not factorable. So if it's not factorable, what do? We cry. No, we don't. We use the quadratic formula or quadratic formula. So, sorry. So again, we're going to figure out the a, b's, and c's. Remember, the a is always the number in front of the a squared. It's literally written in order for you, right? Some people like to just go a, b, c. You could do that too. I don't care. But just don't forget, if you do it this way, some people forget the negatives. So that's why I like to write it out, just to be very clear. And so I don't forget, because sometimes I forget. Like I'll remember it for one of them, but not for the other one. That's me. Okay, so learn from my mistakes, peoples. All right, so here we go. So we're going to go x equals, okay, negative b. So negative of 8, which is negative 8, plus or minus square root b squared. If you do not have the quadratic formula memorized, and then you better at least have it written somewhere very easily accessible on like a, what is it called? A Post-it note, right? And then just put it up here next to your computer so you don't have to keep on like, where is it again on that page? Okay, so have it readily available. You need that all the day long, especially for your test. You know what I mean? You're expected to know that. All right, so, okay. So b squared, so that's going to be 8 squared minus 4. Remember, it's always 4 times a, which is 2, and c, which is 5, all over 2a. So 2 times 2, because it's 2. All right, and then you're going to simplify. All right, so I always simplify this, although negative 8 stays as negative 8. So here you go, negative 8, plus or minus square root. Make it a small square root. Put this in your calculator, or do it in your head, or like right above it. You can be like 8 squared is 64. And then 2 times 4, oh, actually it's better to do 2 times 5, which is 10, times 4, which is 40. And then go, oh, 64 minus 40, I can do that. That's 24, right? But if you're not good with that, if you're not good with mental math, practice or put it on here, okay? But it's good to practice it in your brain, okay? Like writing it out like that. All right, so you should have gotten the number 24. And if you didn't, do it again, like figure it out. Because so many people set it up right and got it wrong on the test. It was so sad, right? And then so there's 24 right there. And most people be like, oh, we're done, because 24 is not a perfect square, so we're done. No, we're not done. Because inside the 24 is hiding a perfect square. So how do you figure that out? So this is why it's good to know your multiplication tables, because I already know in my brain, I'm like, oh, 4 times 6. 4 is a perfect square. So, you know, I would do it that way. But if you're not that good at that, that's okay. We have another way. So, or another way. So here, right here, we have, well, what goes into 24? 2, right? We always use like small numbers, right? So 2 goes into 24 12 times. And then, well, what goes into 12? 2 goes into 12 6 times. Well, what goes into 6? We keep on going. So 2 goes into 6 3 times. Well, what goes into 3? 3. 3 goes into 3 one time. Okay, we keep on going until you get to 1, right? And then usually the last number is going to be the same number as what's inside that you're dividing, right? And you're like, well, do we have any pairs? Is anybody getting married here? We're like, oh yes, these two guys. Remember what I told you? Married people go out of the house. Okay, not officially, just for the radical people. Only radical people do that. So the 2 comes out of the house. So it's going to be 2, because remember 2 times 2 is 4, right? What I said, what's the square root of 4? 2, right? So there we go. And what's left inside the house? The 2 and the 3. So we're just going to multiply them back again. And so that's 2 times 3, which is just 6. Okay? So that's where we got the 2 root 3, root 6 here, right? And then one might ask, well, we must be done now, surely. I'm like, no, not yet. Because if you notice, oh, look, they're all even numbers on the outside of that radical, right? That we need to simplify that some more. They can't all be even, because that means it could be divided by 2, right? So we're going to divide the 8 by 2, which is -4, and the 2 root 6 by 2, where the 2's would just solve then, so we just get root 6. And then the 4 by 2, so which would be 2, okay? So this is our answer. And you're like, wait a minute, Miss Lee. You said that if there are any even numbers in there that we need to divide more. I see that 6. I mean, like, you do. That's correct. But this is not a 6. I know it looks like a 6, but it's really not a 6. Because what is this really? It's the square root of 6. And what is the square root of 6? It's that long number. And it doesn't end ever. So I can't tell you if it's an even number or an odd number, because it literally does not end. It's an irrational number. So that's why we can't do that. Now, if it was like both of them were under, okay, this is never going to happen, because this number on the bottom is not going to be a radical, at least for quadratics, maybe later on when we do other things. But if it was like this, or I should put a 2 down instead, right? Because that's what we're talking about. Then yes, they're both under the square root. Then yes, you could say, oh, 2 goes into 6 3 times and reduce that to a square root of 3, or not reduce, simplify to a square root of 3, because these two are equal to each other, right? So we could do that. But if one's outside of the house and the other one's inside the house, meaning inside the radical, you can't do that. Not possible, okay? So we're just gonna ignore that part, that's it. All right, so now we're going to move on, skip some pages here, because we technically already did this. Remember Elena and Mark, right? Mark had the mistake and he made it, remember, yes. So we're gonna, because we already did this, if you ever want to read this, you can just pause, right? And then just read them. I love them. They're just too funny, right? Romeo and Juliet right here, all the day long. I don't know, I'm thinking this is probably the boy and this is the girl, or maybe this is the girl and that's the boy. I don't know. Somebody's there, right? My favorites. This is the one I promised you guys that I would show you. That's the one. Poor kid. But it's okay. You don't want to date in high school. It hurts your brain and wastes money. Unless it's COVID time, like right now. Then you can't go anywhere. It's like, do you guys just want to just watch a movie on Zoom? I don't know, how's your day right now? I'm not sure. All right, so here we go. We're just gonna look briefly at, because I said we would, at just this graphing. How in the world do you graph a complex number then? How do you graph an imaginary number? Like we can't even do that on a regular X and Y axis, right? So we can't do that on the coordinate plane. It's called the real number. Yeah, anyways. So what we do here, if you notice, it looks exactly the same. But instead of X and Y's, we're using real and imaginary. So we've relabeled them, right? So now the real number line represents the real numbers, and the imaginary number line represents the imaginary numbers. And remember, complex is a combination of those two things, right? So on this line is where all real numbers live. They live here. And on the imaginary line, this is where all imaginary numbers live. And see 0? 0 is so special. 0 is where everything meets. 0 is real and imaginary. Should never thought about that. But yeah, but that's where it's not real. No, it is real. Okay, it's real, but it's not imaginary. Okay, because it's 0i, which means it's not imaginary. So okay, there you go. I answered my own question. Whew, I was going to think about that for a little bit. So how in the world do we plot these things? How do we get these plots on here? Right? If you were not here, try doing it yourself. Well, listen to explanation first and then try doing it yourself and then match up your answers. Right? So if you notice right here, there was a little example here, 2 plus 3i. So if you notice 2 is the real part, right? So remember this 2 is the real, and then this 3i is the imaginary. So we're going to go 2 on the real number line. Then we're going to go 3 up on the imaginary axis, right? And that's literally where our point is. That's where our point lives, all right? At 2 plus 3i. Actually, that's where our number lives, I should say. Okay, and then what about for letter A is 5 minus 3i. How do we do that? Again, it's going to be 5 on the real, so 5 to the right, and then 3 down, because that's where the negatives live, negative imaginary numbers live. But if you're a positive imaginary friend, you live up here. If you're negative imaginary friend, then you live below ground. I'm just kidding. Oh, it's getting late. I need to figure it out. So try these for all of them. The only thing that's a little bit confusing sometimes could be like this row right here. So D is, remember, this is a pure imaginary number. It's solely imaginary. There's no real part to it, right? So negative 6i is just right here, negative 6i. That's it. There's no hint of reality with him, okay? So he's straight up imaginary. So negative 6i. That's why you see him on the imaginary number line, okay? And then if you look at E is negative 7, right? So negative 7 is completely real. There is no imaginary part to him. There is no ifs, ands, or buts about it, right? He is no nonsense. So we go over to the negative 7, and that's it. There is no imaginary part. That's why it's not going up or down, because it's not imaginary. It's just real, okay? It's not imagining things. Okay, but what about I? Like, where do I go with that? So it's definitely going to be imaginary, right? But it's like, remember, I is like a one eye, right? So you literally one eye. So it's right here at F. That's one eye, okay? And then if you have 2i, it's right here. It's 2 eyes. Oh, I'm just laughing by myself. It's okay though. Okay, now when you look at G, you're like, what the what? So remember that the square root, so ignore that. This is I equals 2. Remember what we said it was equal to? Square root of negative 1. They are one and the same. So if they write it like this, don't be scared. Just like take that out, substitute it out, because what did we say I was equal to? Square root of negative 1. So we're going to just replace that with an I. So it's actually 5 plus 3i. Okay? And then you would do the same thing. So please check those and do that same thing with the H and the I. So this is negative 3i plus 3. Notice this is not written in the way it should be written, but that's okay because we can still graph it, right? So we can still plot it. It's be 3 negative. So go 3 negative and then 3 positive, because it's, 3 to the right, 3 reals. Okay, boom, just like that. All right, check it, pause it, do what you got to do. All right, so we're gonna go skip a few, 99, 100. Okay, we're gonna go to complex operations with complex numbers. This is not gonna be on the test, but it's good to know, all right? And I personally think it's very interesting, it's fun, but that might be just me. So again, with operations, you can add, subtract, multiply, and divide complex numbers. You can do all the things that you can do with real numbers, you can do with complex numbers. They're the same, like, it's the same concept, okay? There's only one difference, and we'll talk about that just in a bit. But if you notice right here, we're subtracting, so we're taking 3 plus 2i, and we're subtracting a 1 minus 6i. And if you notice right here, that minus, we're going to distribute it like how we would normally distribute it with like a polynomial, right? With like binomials, right? So notice outside the parentheses for the first one, there's nothing there. So we can just drop, those parentheses are unnecessary. We're just going to go 3 plus 2i. Now, this minus, I change that. So what I like to do is I like to distribute it like this. I just make it a plus and then distribute, make everything opposite, right? So that I can literally see what I'm doing. So that would be negative 1, so minus 1 plus 6i. A lot of people missed that on the test. They didn't distribute to the second term, and it was bad. So you got the wrong answer. Sorry, guys. Okay, so now we're going to take all our real parts, right? So 3 minus 1, which is 2. And then we're going to take all our imaginary parts, right? So that's going to be 2i. So there's 2i right here, plus 6i, which would be 8i. That's it. 2 plus 8i. That's your new number, now that we added those two complex numbers together. All right. And you would just do the same thing here, right? I would look at all my real numbers. So this is 3 minus 6, which is negative 3, minus 1, which is negative 4, right? That's how we got the negative 4. Then we're going to do our imaginary parts. So 4i plus I is 5i, okay? And don't say 5 eyes. It's just 5i. Okay. And okay, so the thing that we need to remember is coming up. So please take note that I is equal to square root of negative 1. That will always be true, always, always, and forever. Hold your peace kind of thing, right? So that's why we don't use i's as a variable, because it's not a variable. We've already gave it a number that it's assigned to, just like pi is assigned to a number, right? E, which we'll learn later on, is assigned to a number. That's why we usually don't see those as variables, because it means something in math. Okay, so if we were to square both sides, right? So that means we have I squared. Well, what's the square of a square root of negative 1? Remember, the square and the square root are inverses, so they cancel each other out. They undo each other. So all we have left is a negative 1. So I squared is equal to negative 1. That's very important for what we're going to do next. So if you take a look here, oh, look, we're multiplying two complex numbers. What in the world do we do, right? The same thing as we would with like polynomials, right? Remember, we do the FOIL thing. Yeah, we do the FOIL thing, so we're gonna just do that. So, and I didn't show you guys in class, so this is the bonus for people who are just watching this, and we're like confused in class or just trying to do it better. So if you can literally just do this. So 5 plus 3i, and this is 2 minus 3i, and then just like how we did with polynomials, right? 5 times 2, 10. 3i times 2, 6i. 5 times, what is this called? Negative 3i, so it's negative 15i. And then 3i times negative 3i is going to be negative 9i squared. What? You can just do that? I times I is I squared? Yeah, it has all the same properties. It's not different. Okay? The only difference right now is that we actually know what I is. And remember what I said, that I squared is equal to negative 1? So we actually have to change that to a negative 1. We can't leave that as I squared. That is not simplified then. So that one is just a negative 1. So what I like to do is I like to cross it off and then just put a plus. Not a plus, I just change the sign. Whatever the sign was, if it was a plus, change to a minus. If it was a minus, I change to a plus, right? Because remember, the negative 9 times negative 1, right? Remember, that's going to be the I squared is equal to a negative 1. So if I were to substitute that in, then what happens? Negative 9 times negative 1 is positive 9, like I said, right? Positive 9. If you want to substitute that in because that's easier for you to understand, then you could totally do that, okay? And then now we're going to take our real numbers, which is 9 plus 10, which is how we got 19. And then our imaginary numbers, and 6i minus 15i is going to be negative 9i. Okay, and that's all we do. And over here, I just, like factored it out, like not factored it out, distributed like how we normally do. 5 times 2 is 10, 5 times negative. So do you see how we all did that? So, and again, here I also did the canceling out thing, or like not cancel, cross out. So that I squared becomes whatever the opposite sign. Okay. So I usually like to do that in different colors. So I can like, did I do it or did I not do it? That's why I have to cross this out. So I know for sure that I did it. All right. Just one more time, if you really, really want to know, right? We can do the same thing here. Let's do something complicated like C, right? So 3 times 3 is 9. 3 times negative 2i is going to be minus 6i. 2i times 3 is going to be plus 6i. And then 2i times negative 2i is negative, what is it? Negative 4i squared, right? And then remember what I said about the I squared? Whenever you simplify complex numbers, you should never, ever, ever have an I squared in there. That means you didn't finish it. It's not done. It's not fully simplified. So that becomes the opposite sign. And what do you guys notice? Do you see what I see? Oh, what? My eyes cancel. My imaginary stuff cancels out. What? Oh, look. It's kind of like the difference of square thing. No, not the difference. Yep, the difference of square thing, right? So this could be 9 plus 4. So this is actually just 13. Remember, normally with our polynomials, we would have a binomial here because we wouldn't be able to combine those, like there wouldn't be like terms that were left over. But since we're not talking about polynomials, it is just i's, then yeah, and that last imaginary one became a real number. It became a real number, like Pinocchio, right? And so now we can combine those like terms. Okay, so we just end up with one real number. Okie dokies. And then we're gonna scroll. And I had said that you should do we did these two. I think one class we didn't do one of them, but one moment. All right, so one thing to do if you look at an equation, if it tells you like any information about like whether it's open up or down, you can kind of predict, you know, are you going to have real roots or are you going to have imaginary roots? And if you look at this right here, this is in vertex form, which means it tells us the vertex. So this is going to be 2, 1, just like that. Remember, that's supposed to be a minus. So that's why it's just 2, 1. And it would be plotted in the first quadrant right there. And we know it's open up because the A is positive. Notice I circled that. There's nothing there, which means it's positive. So it's doing one of these, open up. So we're like, oh, look, it's not going to ever cross the x-axis. So we know our answer should be imaginary. So we're already thinking ahead, like, okay, if I don't have imaginary roots, I did something wrong. Go back and check it, right? So here we go. So we're going to find the solution to this. Notice we only have an x in one location, which means we're just going to solve for x. And if you don't remember that, go back to the beginning of this equation, of this video. Copy that down. All right. So we're going to subtract 1 first, and then we just have the square. So to get rid of that square, we got to square root both sides, right? I don't know why my square root is so long. Oh, that was just not, that was the equal sign. Never mind. And then, so we're going to square root both sides, and we get x minus 2 is equal to plus or minus square root of -1. Well, what in the world is square root of -1? Well, we know that. It's I, right? So we're going to just replace that with I, right? But so how do we get rid of this -2? We're going to add 2 to both sides. And so you get x is equal to 2 plus or minus I. That's it. That's your answer. Nothing we can do. We can't come. Remember, we have a real and an imaginary. We cannot combine those together. They do not combine. That's the number. Okay, that's, yeah. And then we're going to go to the next one. We have this function right here. And we're going to try doing it with the quadratic formula, right? And you may or may not need to do this, but an easy way to check is if you don't want to go into like to do the whole quadratic formula, but you want to just check what kind of roots do I have, then you can just do the discriminant, right? Which is just the stuff inside the radical, which we call the radicand, not the radicant, the radicand. All right. So that's gonna be b squared minus 4ac. So that's gonna, so remember our a, b's, and c's from right here, it's all in order. A is 1, b is -2, and c is 2. All right. If you want to write them just like that. So here's a, b, and c. Again, I don't like this way sometimes because you forget like there's the -2, or some people use x. Like, no, you're not gonna have x, put it into x, like that. Can't do that. All right, so, and then they get confused. So here's b squared, so -2 squared. Please make sure you have the parentheses there. If you don't have it there, it's gonna give you the wrong answer. All right, so -2 squared minus 4ac, and then do some work. So -2 squared is 4. This is 8. And yes, we get a negative number, which is right, because what happens when we have a negative number in a square root? Imaginary, okay, and this is what we're expecting. So we're gonna plug it into the whole quadratic formula, right? So -b, well, b is already negative, so what's the negative of that? +2, right? So +2 plus or minus square root of this guy right here, right? That's, we already found that, right? So we don't have to redo it again, right? So that's the square root of -4, and then divided by 2a. Well, where's the a? Well, a was 1, right? Well, 2 times 1 is 2, right? And then, so now we're going to simplify some more. And we know that the square root, okay, if there's a negative inside, we're definitely dealing with an I. There's an I problem here, okay? And an I problem. And then, so what's the square root of 4? 2. So it's 2i, right? And then, so this is going to be 2 plus or minus 2i divided by 2. And if you leave it like that, I'll be like, simplify, right? What goes in, well, I noticed 2 goes into 2 one time. Then 2 goes into 2i one time. So that's what we left with, just an I, right? So my literal answer is going to be 1 plus or minus I. Okay? 1 plus or minus I. That's it. Okay, and I said you can practice some more here. Okay, again, we're not going to really be testing on this, but actually we will be testing on this. You're going to need to know if you have imaginary roots, you're going to have to figure out what those are. So yeah, let's do it. If you didn't do number 8, do number 8. Okay, figure it out. Okay, try the A, B, and C, and then we'll do it together, or I'll just do it by myself. All right, so it says use any method to determine the roots of each, the zeros of each function. I'm like seeing things. Okay, so I'm going to first see, I don't like this negative out here, so I'm going to factor that out. So I want to see if it's factorable. And then this is going to be plus 8x plus 18. Why? Because when I multiply this back in, negative times negative x squared is negative x squared. Negative times positive 8x is negative 8x. And negative times a positive 18 is a negative 18. It all works out. And if it doesn't, then you did it wrong. Okay, so I know this is going to be 1 and 1. And this is going to be 2 and 9. Is 2 and 9 going to give me 8? No. 3 and 6. 3 times 6 is 18, but 3 and 6 is not going to give me 8. Is there anything else? I don't see anything else. So not factorable. So what we're going to do here, so we're like not factorable. Factorable, if I can even spell it. So we're going to go with A, B's, and C's. So A is equal to -1. B is equal to -8. I'm just going to go with the original. And C is equal to, as which you should do, because you should always do it in standard form, which that is. If you do it with the negative on the outside, you're not going to get the right answer because you're not including that negative in there because it needs to be in standard form. Has to be. All right. And C is equal to -18. All right. And X is equal to, so X equals negative B, negative of -8, 8, plus or minus square root B squared. So -8 squared. Minus 4 times A, which is -1, times C, which is -18, all over 2 times A, which is -1. Okay, I'm going to have to simplify that down. So let's try this out. So X equals 8 plus or minus, what could that be? I'm going to do this on my calculator. So I'm going to put in, so -8 squared. Please make sure you put in the parentheses. Minus 4 times -1 times -18. Notice when I'm multiplying, you don't have to put in the negative, so I don't. This is what I got. Did you get what I got? -18. Oh, so I mean -8. Okay, so that should be -8 right there. Over -2. Now I need to simplify because I noticed that 8 has a perfect square in it. It has a 4 in there, right? But if, let's say I didn't know, and I'm like, I don't remember. Or you're like, what? There's a perfect square in there? So I'm like, okay, 2 goes into 8 4 times. 2 goes into 2 2 times. Then 2 goes into 2 1 time. So, and I have one pair right here. See, there, that's my 4. 2 times 2 is 4. What's the square root of 4? 2. And then this is, my leftover is just 2. All right, so this is actually going to be 8 plus or minus 2i, don't forget the I because that was a negative in there, root 2 over -2. Now the question is, are we done? We're not done. We need to actually divide this in because they're both divisible by 2. So we're going to just finish it off by going -2 goes into 8, -4 times. -2 goes into -2 goes into 2, 1 time. So it's going to be plus or minus. Honestly, it doesn't matter about the negatives because we're already dealing with the plus and the minus. And so we just leave it as plus or minus. I, 2. If you do it that way, that's fine. If you say this, because you're like, but the I has to go in the last place. If you go like this, that's fine. Just make sure that it's not over. Because that would be wrong. Okay, so that's what that is. Okay, that's our answer. That's it. All right, so for B, we're going to do the same thing. Some of you guys may have been like, but Miss Lee, you didn't set it equals to 0. I'm like, I'm sorry. I did that in my brain. Okay, and then A is equal to 2, B is equal to -2, and C is equal to 3. All right. So here we go again. So X equals -B, negative of -2, positive 2, plus or minus square root B squared, -2 squared, minus 4 times a, which is 2, times c, which is 3. All over 2 times 2, right? Okay, so now let's figure this. So we don't have to simplify that, the 2, but what's in the square root? That's 4 minus 24, 4 minus 24, which is negative 20. Yep, minus 20 over 4. All right. And as you can see, we can totally simplify that. You never want to just leave it as that. You have to bring in the I. Okay. I am seeing if you can recognize that. So 2 plus or minus. So again, 20 definitely has a square root, a perfect square, right? So another way that you can do this be like, oh, remember it's like 4 times 5, right? Because I'm picking 4 instead of 2 times 10 because 4 is a perfect square, right? So what's the square root of 4? 2. So this is 2. Don't forget your I because that was negative in the inside. Square root of 5. Okay, and then over 4. Phew, we're almost done. Actually, we're not done. I said we're almost done, right? So remember all of these numbers on the outside, it is all divisible by 2, so we have to divide it. Keep on simplifying, get used to it. It's expected. So 1 plus or minus 1, how did I get 1? Because 2 divided by 2 is 1. And 2i divided by 2 is I root 5 over, oh, I almost did not divide the 4 by 2. Had to divide that one by 2 as well. All 3 terms have to be divisible by 2. Okay, and that's our answer. All right, same thing with C. All right, we'll do this really quickly. This is going to be, I'll do this my mode because I gotta go. So x equals negative b plus or minus square root b squared minus 4ac all over 2a, right? And that's going to be negative 4 plus or minus 16 right there. That's 1248. That's going to be 32, so negative 32. And it's going to be over negative 6. So that, my perfect square is 16, because this is going to be 16 times 2 is 32. So it's going to be negative 4 plus or minus 4i, right? Because 16 square root of 16 is 4 over root 2, negative 6. Everything is divisible by 2, so it's going to be negative divided by negative is 2 plus or minus 2i root 2 over 3. Okay, and that's going to be your answer right there. All right, and again, we're talking about this one when it is the vertex, remember the highest point is above the x-axis, right? It says above the x-axis and is open down. We have 2 x-intercepts, that is 2 real roots. If you did not do this by yourself first. Okay, if it's below, so if the vertex is below the x-axis, right, and it's open up, again, we have 2 x-intercepts, and that's 2 real roots. But if it's open down, right, we would have 0 x-intercepts, and it's 2 imaginary roots. And what if it's right on the x-axis, right? Then it's 1 x-intercept, and it says, we would just say 1 double root. I guess we could say 1 real double root, although it kind of assumes that. But anyways, and same thing with this one, 1 real double root. All right, guys. I will see you guys later, okay? Bye. Hopefully that was helpful.